Welcome back to Chemistry Clubhouse. Today we're going to go through a few problems that deal with calculations pertaining to pH and pOH. So let's get started. Here's the first problem. Using solid KOH, make a 250 milliliter solution that has a pH of 12.5. All right, so let's figure out what we have. What we're trying to solve for is mass of KOH. That's what we're looking for. We need a volume of 250 milliliters, which is equal to 0.25 liters. And the pH needs to be 12.5. Now, right off the bat, we can see that the OH and the H do not agree with each other. So we're going to use that first equation. pH plus pOH equals 14. If we plug in our values, we have 12.5 plus pOH equals 14, which means my pOH is equal to 1.5. All right, so that's great. To get back to mass, we need moles. So we're going to have to use our next equation. All right, so we have pH, which corresponds to a concentration, but it's not really concentration. So what we need to do is figure out what the concentration of OH minus is. And that's going to be equal to 10 to the negative pOH, which is equal to 10 to the negative 1.5. If we plug that into our calculator, we have, give me a second, not the calculator I'm used to using, 10 to the negative 1.5, and we get 0.0316 molar OH minus. All right. Now, NaOH, wrong substance. KOH, when it dissociates in water, it turns into K plus OH minus. So when it breaks up in H2O, so sometimes you might write it like this, water makes it break up or dissociate into K plus and OH minus. Now, if this is 0.0316 molar, then this also has to be 0.0316 molar. And if we continue, this must be 0.0316 molar. All right, so this turned into this and this. Okay, so if we know that the molarity of OH minus is 0.0316, then it must have come from a 0.0316 molar KOH solution. So my concentration of KOH is equal to 0.0316 molar. So now we've got molarity and we've got volume, which we can go to the third and final equation. Molarity is equal to N over V. We got molarity, which is 0.0316 molar KOH is equal to N over 0.25 liters. And if we do that math times 0.25, we get N is equal to 0.0079 moles of KOH. Now that doesn't answer our question. Our question is, again, up here, is our mass. So how many grams? So we have to do our little dimensional analysis. 0.0079 moles of KOH times that by 1 mole of KOH is equal to 56 grams, if I'm not mistaken, 56.1 grams of KOH. And if we multiply that, we end up getting 0.443 grams of KOH is needed. So if we were to do this, how we would make our solution is we would take 0.443 grams of KOH and dissolve it in enough in a volumetric flask into a 250 milliliter flask, and you would have a 12.5 molar solution. All right, let's try another one. So question 2. What is the pH of a 300 milliliter solution of 0.0035 molar NaOH that is diluted to 500 milliliters? All right, so we have a volume 1 is equal to 300 milliliters. we have solution, so our molarity 1 is equal to 0.0035 molar NaOH, and it's diluted to 500 milliliters, so our V2 is equal to 500 milliliters, so our molarity 2, we don't know. So again, M1 V1 is equal to M2 V2 if we use our dilution equation. So we've got 0.0035 molar times 0.3 liters is equal to M2 times 0.5 liters. So M2 in this case, so if we do our math, we have 0.0035 times 0.3 divided by 0.5, and we have a molarity of 0.0021 molar, which makes sense. It's less molar or less concentrated than the first molarity, so it's diluted. So this is our next molarity. Let's add to that because that's important. It's our molarity of NaOH. Now we are still looking for pH. So we've got our concentration of OH, or NaOH, but again, like I said in the last problem, NaOH and H2O breaks up into Na plus OH minus. So if I start off with 0.0021 molar of this, I'm going to have 0.0021 molar of this in solution because this is going to break up into that. So now we have our concentration. So this is our concentration of OH minus. So now, once again, we have our concentration of OH minus, and we have our need for pH. So now we just need to use an equation. pH is equal to negative log of concentration of OH minus, and I'll take that back. That is definitely not pH. That is pOH, is our concentration of OH minus, which we have right up here, which is equal to the negative log of 0.0021. And if we calculate that, negative log of 0.0021, we get 2.68. So that is equal to our pOH. But again, we're not done. We need to get pH. So pH plus pOH equals 14. So pH equals 14 minus 2.68. If you redo the calculation, 14 minus 2.68 is equal to 11.32, which is what our pH is, and that would be our final answer. Again, if you look, we're using multiple equations. So we're using that equation, we're using this equation for this problem. Oh, and we're also using this equation. So we've got 3 equations that we're using here in this problem. All right, this final question. Your stock solution of 6 molar nitric acid needs to be used to make 100 milliliters of a pH 1.25 solution. Provided instructions for this process. Okay, so we've got our stock solution, which has a molarity is equal to 6 molar. Our volume of that, we do not know. We have a volume 2, which is 0.1 liters, or 100 milliliters. And we have a pH, which is equal to 1.25. And again, this is nitric acid, so it's HNO3. All right, now these two agree with each other. I've got an H and I've got my pH. So these are in agreement. I don't need to change it to OH. I don't need to do anything with that. So what we need to do with this is get it into a workable concentration. So our concentration of H plus is equal to 10 to the negative 1.25. And if we do that, we have 10 to the negative 1.25. Oops. 10 to the negative 1.25 is equal to 0.0562 molar H plus. And like I've shown you on the last 2 problems, we know that HNO3 breaks up into H plus NO3 minus. So if this is this number, then we know this had to be the exact same. So this is also equal to our concentration of HNO3. Well, where are we going to get that concentration from? Well, we're going to get it, that's going to be in our 100 milliliter solution. So we've got our volume, which is 100 milliliters, and we've got our concentration. So we've got M equals N over V. Or we can just do a dilution problem again. We're going to do it this way, using M equals N over V. So we have 0.0562 molar is equal to N over 0.1 liters. And my N is 0.00562 molar HNO3. Now we're going to get that from our stock solution. So we have to use our M. So this was M2 and this was V2. So we are going to do our M1 is equal to N over V1. Well, we have the molarity, which is 6 molar, which is equal to our molar, we're getting that 0.00562 moles. Oops, that's supposed to be moles down there. Moles of HNO3 in our V1. And if we calculate this, it ends up being 0.00937 liters, which is equal to, times that by 1,000, and we get 9.37 milliliters. So this is our answer, but it doesn't answer our question. Our question says, provide instructions for this process. So 1, measure 9.37 milliliters of stock 6 molar HNO3. And then we are going to mix with, now we could just say put it in a 100 milliliter flask, or sorry, 100 milliliter volumetric flask, or we can go 100 minus 9.37 and say mix with 90.63 milliliters of distilled water. And those would be our instructions, and this would be our answer. Again, we're using multiple equations here. We've got this equation here, we're using this guy again, and we're using this guy. What we could have used M1V1 equals M2V2, but again, whatever works best for you. I've shown you both methods, both work. You're just going to be using these multiple equations to hopefully figure out these answers. I hope this helps. Good luck, and I'll see you next time.